Hi, welcome to the 11th episode of Coding with Amadeus. In this series we're building a smart mirror using Raspberry Pi running Windows 10. And we're almost done, but before we put our device on the wall, we need to be able to handle any issue that may appear down the road. In this episode we'll talk about exceptions. What are they and how to use them well? And we'll also use AppInsights to track both errors and normal usage of our smart mirror. So let's set up AppInsights first. It's an Azure service with a very large free tier. Signing up for Azure is outside of the scope of the series, but I'll show you now how to set up AppInsights into your existing subscription. I'm on portal.azure.com and I'll click New, and in the search box I'll type AppInsights. And there they are from publisher Microsoft, and we'll hit create. I'll call it Smart Mirror Insights. Application type, I guess it will be a Windows Store application. This is my subscription. Everything looks okay. And in a few seconds it will be done. Here it is, our AppInsights resource has been created. There's nothing going on here yet, so let's go to Properties and we'll take the instrumentation key. This is the GUI that we will use in our Visual Studio to hook up our Smart Mirror app to this resource. AppInsights are set up in the constructor of the app. When we created the project for the first time, Visual Studio added those few lines. It initializes AppInsights, and here we have two options of initializing it. We can either provide the instrumentation key here into the source code, or we can take this route where the key is provided through the configuration file. And that's what we'll do, because I don't want to store the key in source control. So let's go to applicationinsights.config. And this configuration file is pretty empty. So we'll create a new element, and the new element is called instrumentation key. And here we paste the key from Azure. Through this function, initialize async, we can set up a bunch of application insights tracking for free. So I'll hit enter here and hit control space, and now IntelliSense pops up with suggestion that I use this enumeration. Hit dot, and I see that we're not using page view and unhandled exception. So this is great. Page view means that every single time we navigate to a different screen, we'll get an event about it. And another one is unhandled exception. These exceptions are the worst because they completely bring down the application. And in case this happens, we'll know about what happened and what caused it. We'll talk about exceptions soon. We'll actually try to make sure that there are no unhandled exceptions. But for now, let's just send some custom application insights. Let's go to the bottom of the onLaunched method. When everything is set up, we'll create a new variable of our TC for telemetry client equals new Microsoft Application Insights telemetry client. And now we can say tc.track. And here we see a bunch of things that AppInsights can do for us. We can track an event, we can track exception, metric, page view, request, and trace. And I would focus on tracking event, exceptions, and metrics. So for now we'll use track event, and the event will be hello world. And now we can pass in those properties here. We can also pass metrics if we created another dictionary with doubles, but we're not going to do it for now. Let's just see if everything works. And let's try to go around the screens, and oh, here's an unhandled exception. I guess we'll test how unhandled exceptions are handled. Okay, it totally crashed. That was pretty eventful for the first run. Let's see how Application Insights displays all this information. Here we have a timeline that shows page views, sessions, users, here also sessions. And what really interests me here is crashes and custom events, because these are the events that we explicitly told AppInsights to monitor. We track an event called Hello World, and we pass in properties a dictionary with two keys, username and location. And here we see it, custom event, Hello World. We can click on it. And here we see custom data, location, username. So this data is strings, it's just being displayed in the table. But if we were to use metrics right here, which is a dictionary of doubles, then AppInsights would draw a graph of those metrics. So you can really put any information you want and see how this data changes over time. And the most important thing for us is crashes. This is that unhandled exception. Let's dig deeper into this exception. We see some details about my machine and the version of application. And here's the actual exception, so let's drill down here. And we can see the stack trace. We can also see all telemetry that happened in this user session, so you can actually backtrack and see what led to this crash. Sometimes you might find very valuable information about it, because some crashes are triggered only after a specific chain of events. So we can see that there was a custom event, Hello World, then we went to the clock view, and then the exception happened when we were trying to navigate somewhere else. There are some fantastic resources on exceptions online, and I linked some of them in the description below. The first one, the exception model, is a fairly long read, and it talks about how CLR is handling exceptions behind the scenes. Then we have the true cost of .NET exceptions. It's very quick, and it explains what is the actual expensive part of the exceptions. Next, we have the design guidelines on exception throwing. It's fairly quick to read, and it's packed with information. I really recommend you read this one to know when to use exceptions, how to use exceptions, and how not to use them. And there's a very interesting read, the error model, which goes over how errors were handled throughout the history of computing and how it's been done in different languages. Now I will try to condense this information and present you with the gist about the exceptions. Every program has some sort of an entry point, the first method which is being executed, and then from there on we call more functions. So we have the entry point in a console application, that will be the static void main method. And then this method invokes more functions, and this way we're building the call stack. Each element of the stack here is a function. When some functions return, they are being removed from the stack, and then we call more functions and they're being added onto the stack. Now suppose we'll call a function which will throw an exception. So we're calling this function, it's added to the stack, and it throws an exception. And now what happens when we invoke the throw statement? There are a few things. First, we are creating the exception object, and we are populating some fields of this object. For example, we're taking information about the stack and we're putting it into the exception. Then we are unwinding the stack, so the CLR will actually go back one by one method, looking for a method that has a suitable catch or finally block that will be able to handle this exception. So in this example, we are unwinding the stack, and without finding any method with a catch block, the application crashes because we reached the entry point and the exception is still outstanding. Another entry point in our application are UI events such as keyboard, mouse, touch. Here, the green rectangle represents a function with a catch block. If an exception happens down the road, CLR will unwind the stack to this function, and then in this function this exception will be hopefully handled. There are also programmatic event handlers, such as network calls or timer elapsed events. Code invoked by those event handlers also needs to be properly safeguarded against the exceptions. We also have a special case when it comes to the async methods and specifically resuming those methods. Here I colored those rectangles purple. This code has been run before we await it. So we have some code which has a catch statement here that calls some methods, and here is when we await on an asynchronous method. Then the asynchronous call completes and we resume the execution. And the execution continues. And if we were to have any exception here, the stack would be unwound all the way to this catch block. But this is only if we are using method with a signature async task, because the task carries this information across the boundary of awaiting. If you were to use an async void method, this information is gone. And now look what happens. We have no knowledge of the catch block. And if there's any error right here, it would percolate all the way up to the entry point and then your application would crash. So don't use async void. And if you do use async void, try to make a catch statement somewhere here so that all the exceptions are caught. Let's quickly talk about the performance. I said that when we use a throw statement, there are three things happening, and all of those three things are very expensive. First, we're creating an object, exception. We are populating its fields, and we do it using reflection. We need to take a look at the call stack, analyze it, make it to string, and put it here. Then we unwind the stack. We're going up method by method, checking for a catch block, and then we access the catch block. And usually the catch block is not in your cache because it's rarely used. Maybe catch block is invoking some logging method, and the logging method might make a page fault because the code is not even in memory. So throwing of exceptions is expensive, but using try and catch blocks, it's not expensive. So you should do that, but remember to use exceptions only for the exceptional situations. I want to provide a gradual loss of functionality in case of any errors. If, for example, we cannot access the weather service, let's just remove the weather module from the smart mirror and let's leave the clock and transit modules. We'll definitely say that smart mirror has loaded. If anything goes wrong here, we'll say TC, TrackException, and now we'll pass the exception right here. Alright, now when we do that, we will send the information about the exception, and we'll also specifically say that this happened in a clock module. Alright, so we'll do the same thing for the weather model and for the transit model. And let's dive deep into the weather model, for example. Here we are doing web requests, and this is a thing that usually fails. It can fail for many possible reasons. One of them would be the domain is incorrect. So here instead of .com we have .com. So let's run it and see what happens. Alright, we received an exception. The exception has a message, the server name or address could not be resolved. And we also specifically say that module weather is the one at fault. And now we can see that we have only the transit module and the clock module. So this works as expected, and Application Insights says that it sent 5 items. That's great. Let's dive deep into the weather model and see what else can go wrong. Suppose we provide the wrong API token. This way, when we reach the update with 10-day data, we won't get the expected response with JSON containing a forecast and simple forecast day. So we're gonna get a null reference exception. If we go to immediate window, we can try a JSON forecast. It is null. So there will be an error happening right here. In spirit of what we just learned about exceptions, we're using exceptions only for the exceptional situations that are really difficult to think of and really difficult to deal with. And here it looks like a fix is very simple. Let's just see if JSON forecast exists. If it does, that's great. If it doesn't, then let's handle that, but let's do it without using exceptions, which are expensive. Here's a very interesting pattern, the try pattern. We have JSON.tryGetValue, and tryGetValue takes the first parameter proper name, forecast, and the second is out JToken. So we need to create a JToken earlier. We won't assign anything to it, and then we'll pass it here with the special out keyword. So JToken, forecast token, and let's say if this succeeds, then we'll do the special operations. Or actually, if it doesn't succeed, then we have an error. Alright, so now if we don't have the forecast value in the received JSON response, we're gonna notify us. We'll say that the response is the parameter response, so that later when we're looking at the exception, we can analyze this response and figure out why we have an error. And instead of TrackException, we don't have exception, so we'll TrackEvent. And the event would be, it will be an interpolated string where we say that we received an unexpected response. And we'll pass in the name of this method. Update with 10-day data. Alright, let's clean up this code real quick. We can actually use the forecast token right here, and we'll use the same code in this method, update with hourly data. Okay, I think this is it. And one more place where we're doing API stuff would be the transit module. So right here we are also using the API key, and this request can fail. And since it's a dynamic object, if we're trying to access a property that doesn't exist, we're just receiving a null, and it doesn't throw any exception. But we don't want to continue any further without the API key. So let's actually throw an exception. If API key, if string is null or empty, API key, we'll throw API key for the transit module is invalid or is missing. And this way, this error will be thrown and caught right here. So now instead of getting more bogus information regarding parsing of a response, because the response has an error, we're gonna have a more meaningful error right here, that in the transit module the API key is missing. So exceptions are very much a thing for a developer to use and enjoy. You just need to use exceptions in the right places, and don't catch them immediately. Don't catch them just for the sake of catching them. It's okay to let the exception percolate up the call stack until it hits the right place to handle it. And remember, if it's possible to not use exceptions, do that. And here I'm actually using exception because there's nothing else for us to do here. And this thing happens only once. We only once initialize the model. If it doesn't work, then it's gone. But if you have code which is being invoked a lot, rapidly in succession, then the performance hit of exceptions is really bad. So in this kind of code, try not to get to a situation where an exception is necessary. So try to do checks at runtime, and if the checks fail, then just don't do an operation instead of doing it and getting an exception. And the last thing to keep in mind, here we have an event handler, and if there's anything going wrong in this event handler, then this exception will be left unhandled. So here we're doing some pretty serious stuff. We're doing navigate next, and from here we're launching a callback. So now it means that we are allowing some developer to provide a callback, and this callback can have any exceptions. We have really no idea what this callback is, and we're never handling this, so this is very bad. So probably here we should do a try catch. So this should do the trick for now. I will commit that code, and as I continue working with this, I will probably handle and throw exceptions in more places. And in the next episode, we're going to look at the XAML and the GUI design, and I'm really stoked for it because it means that we're going to put the smart mirror on the wall really soon. Thanks for watching, and I'll see you soon.